In this video, we're going to go through exact differential equations, and we're going to try to solve a good number of questions under it. Now first, what is an exact differential equation? So let us say we got a function u, and the function u is a function in terms of x and y. Now how can you find the natural or the total derivative of the function u? Now if you wanted to write that, that is going to be as du. This will be representative of the total derivative or the natural derivative. Now in order to find that, we need to take the partial derivative of the function u with respect to x, and then we need to add it to the partial derivative of u with respect to y. So that is going to be partial u, partial x, and that will be multiplied. I think I'm just going to create a bracket here, and that will be multiplied by the natural derivative of x. You need to add that to the partial derivative of u with respect to y, that multiplied by dy, that is natural y. This is going to be the representation or the equation that stands for the natural derivative of the function u. Now from here, I could well do something. Let us see that this stuff is called as an m. And if we have this stuff to be called as an n, what that means is we have m to be equal to partial u, partial x. So that is what it is. Now for n, you got something like this. This is going to be partial u or partial y. So that is what it is. Now, having got this, we need to find out something more. If we replaced this stuff as an n and replace this as an n, what are we going to have? So we're going to have something like this. This will be du, and here we're going to have a m dx. This is going to be plus n dy. Now, let us say that du, that is a natural derivative of u. Let us say that is equal to 0. And if we got that, what that means is you got a 0. This is going to be a 0. That will be equal to m dx plus a n dy. Now, this stuff which you see here, this is what is called the exact differential equation. So you're most likely going to see many questions given to you in this form, and you would actually be asked to find out whether or not the equation is an exact equation. So how can you do that? How can you find out whether or not an equation is an exact equation? How can you do it? Now, in order to do that, we need to know that m. First of all, we know that m is equal to delta u delta x. That is a partial derivative of u with respect to x. Now let us say I wanted to differentiate both sides with respect to y. So this is going to be partial n, partial y. And this will be equal to partial y of this whole stuff. That is partial u, partial x. That is what you're going to have. Now in that case, you're going to have something like this. This will be partial m, partial y. And on this side, we're going to have a partial squared u divided by partial y, partial x. Now let us try it for the function n. That is a partial u, partial y. Now in order to do this, we need to take the derivative of both sides with respect to x. So this is actually going to be partial n, partial x. This will be equal to partial x of this function. So I think I'm going to rewrite that. So let us make it this way. You're going to have this. This is what you got. So for now, I think I'm going to wipe these off. So you're going to have partial n, partial x. That will be equal to partial square u. This will be divided by partial x, partial u. So you need to take note of these two equations. Now, as you can see, we know that this stuff, this is the same thing as this. Because from differentiation, you can have d squared u dy dx. That is actually equal to d squared u dx dy. These, these are actually equal. They're similar and the same. And because we do have it this way, we're therefore going to say that partial m partial y, that is equal to partial n partial x. Now you need to understand, this is actually the condition that makes a differential equation to be an exact. So you really need to take note of this. This stuff, very useful. So we're going to try some questions under this topic to find out how stuff works. So the first question is, you need to find out whether or not this is an exact equation. And if it is, you need to solve it. Find out what is going to be the solution to it. So we got plus of this x squared plus a x plus a 1 dy, well, and this is equal to 0. So feel free to pause the video and try to solve it. And the first thing you need to do, you need to make this stuff as an m. And this is going to be an n. Remember, we had m dx plus n dy equal to 0 as original stuff in it. This is what we had originally. This is an exact differential equation. So in that case, we're going to see that m, that is equal to 2xy plus a y plus a 1. Now this stuff, we need to differentiate it. Now what are we going to differentiate m with respect to? We know that m originally was actually the derivative of u with respect to x. Now we need to work dm dy. So we need to differentiate this with respect to y, which is actually going to be pretty much the same thing as a d squared u dy dx, something like this. So let us find out what this is. So this is going to be dm dy. That means I need to differentiate this with respect to y. Now in this case, as you can see, we actually have a 2x as the coefficient of y. So in this case, we're going to make 2x as the constant, which stands as a coefficient. So that is still going to be there. Now the derivative of a y, that obviously is a 1. The derivative of a y here, that is still going to be a 1. And this is a constant, which stands alone with no variable attached to it. So if you wanted to differentiate this, that is pretty much going to be a 0. So this should be 2x plus a 1. This is the answer for dm dy. Now let us try to find out what the n is. So we got n. That is equal to x squared plus a x plus a 1. Now what is going to be dm? Well, dn dx. So if we want to find dn dx, that is, we need to differentiate this with respect to x. Now the derivative of x squared, that is going to give us a 2x, and the derivative of x, that will be a 1. So here, as you can see, we have a 2x plus a 1 from the first case, and that is actually similar to what we have in the second case. So in this case, we agree that partial m partial y, that is equal to partial n partial x. Now since we got this, that is going to make it be that this equation is actually a differential, exact differential equation. So that is the first step. Now we need to use some of them in order to find out what will be the answer or the solution to this differential equation. So I think now I'm gonna take these out. So first, we know that m, that is equal to 2xy plus a y plus a 1 and n. N is equal to, well, so that is going to be x squared plus a x plus a 1. Now we know that m is the same thing as a partial u, partial x in it. Now this is actually the partial u, partial y. That is what we said. So I'm going to take these ones out. Now next up, what I need to do, I need to find out what is going to be the integral of n dy. Now we already know what n is. N is the same thing as a partial u, partial y. That will be multiplied by the natural derivative of a y. So in this case, this should obviously take us to some minute. Now, if we wanted to cancel, that is take this dy away with this one, we're actually going to have something like this. This will be integral du. Now, this is obviously going to cancel, and that would obviously take us back to a u. So what we're trying to do is to find out what is going to be the u. In order to do that, as far as we got this stuff as differential equations, you basically need to integrate them in order to take it back to the original stuff. So that is basically what we're going to do. Now we're going to use integral and dy. So I'm going to take these out. Just hold these at the back. So that is going to be integral and dy. Now we know that n is equal to this stuff, which you see there. So this should be integral x squared plus x plus a 1 dy. Now what is the meaning of this? What does this mean? So this, what you need to do is you need to find the integral of every term within that expression with respect to y. So how can we do that? Remember, we have this as an antiderivative. So we want to find out what is going to be given if you actually integrated this with respect to y. Now remember, we do not have no y here. So what I'm going to do is this. So this is going to be, we know that this is going to be x squared standing as a constant. Now bear in mind, if you differentiate a constant, that is going to give you a 0. But if you integrated a constant with respect to whatever variable, so let us say you integrated k dy, that should take you to a ky. So that is what we're going to do. Now we already know that if you have integral this without no y's attached to it, what that basically means is that you got a y to the 0th power. Now in order to integrate this rather, you need to place a k, which is a constant, without. Next up, you need to add a 1 to the power and divide it by the 0 plus a 1. Now there is already a video which I've actually uploaded on integration. So feel free to check that out on the channel. So in this case, we're going to have a k. That will be y to the 1. That will be divided by 1. This obviously is going to give us a ky. So as you can see, we actually have a ky giving a k over here. Well, giving a ky. So if you integrated a constant, you're going to take the variable, which was actually, that is a variable that you use to integrate the constant with respect to. You need to attach it at the end. So basically, this should be a y attached to x squared. So this is going to be an x squared y. So that is basically it for that one. Now for this one, we're going to have a xy. Now here we have a 1. Now remember, if we got a y and we wanted to differentiate this would have given us a 1. So we want to take this back to the original stuff. And that is by the method of the antiderivative. or what you call as the integration. So here we should actually have a y. This is basically going to be the answer. Well, we need to add a t of x there because there must be a constant at the end of an indefinite integration. And that must be with respect to the other variable which you didn't actually take as the reference for this integration. Remember, we integrated this whole form with respect to the y. So I think I'm going to leave it this way. So this is actually what you're going to have. Now this stuff which you see here, this is kind of a u. Remember, as we said earlier, feel free to rewind the video and find it out. We actually said that if you had integral in dy, that should actually take you back to a u in it. So here we're going to have a u. Now next up, we need to differentiate this with respect to x. Now we already have a y variable here, so obviously this should be a partial derivative. So this is going to be partial u, partial x. Now I need to differentiate this with respect to the x. So y is going to be seen as the coefficient. So we need to differentiate x squared, which is going to give us a 2x. And on this side, we're basically going to have that is going to give us an x. Well, that is a mistake. I'm actually making the derivative with respect to x. So in this case, y stands as the coefficient, which is basically going to be set out. Now this stuff, x rather, if I differentiated x, I'm actually going to have a 1. So that will be multiplied by a 1. Now on this side, this is basically a constant as far as we do not have an x attached to it. So that is basically going to be wiped out. Now this is also a constant, but in this case, it's actually similar or synonymous to this stuff because we are actually making this derivative with respect to x. This is actually a constant, which is a variable in some ways. So if I wanted to differentiate this, I would basically have a derivative form of that function. Now, if you took this to multiply with a 2x, that is going to give you 2xy. Now, if you differentiated this, or added that rather, that is going to give you a y. And then on this side, we're going to have a t prime of x. So basically, this is what we have. We have a du dx here. This gives us 2xy plus a y plus a t prime x. Now, remember, we already had something from the beginning in it. We had this. And this is actually du dx. There is another du dx here. Now, these are actually meant to be equal. Notice that for this one, we have a 2xy. And similarly, we have that on this other side. And we also got a y, and here is also a y. So it is only a 1, which is not present within this place. So we could well equate or compare each term within each of these derivatives in it. So if we got partial u, partial x, to be equal to itself, therefore we're going to have a 2xy plus a y plus a 1. That is going to be equal to a 2xy plus a y plus a t prime of x. I need to take these out. Now from here, we know that this is going to get cancelled. This would also cancel out. So we're basically going to be left with 1 being equal to t prime of x. Now how can you get this? We know that this is actually the derivative form of the function t of x. In order to take it away from the derivative form, we basically need to differentiate both sides in it. Now in order to do that, this is going to be integral this. I think I'm going to write it on this other side. So this is integral 1, and that would obviously be equal to integral t prime of x. So basically, you know, this should be integrated with respect to x in it. Now this is basically going to give us if you integrated a 1, that is with respect to x raised to the 0th, because obviously this is basically what it is. Now here you got 1 x to the power of a 1, and that will be divided by 1. So in this case, we actually have a x before there. So therefore, we got t of x to be equal to an x. This is going to give us an x. And here we're going to have it reduced to a t of x. So in this case, we actually know what t of x is. T of x, that is equal to an x. So I'm going to rewrite this now. This is going to be u. U, that is equal to x squared y plus a xy plus a y plus a x. So this will be basically, this is going to be the answer to the question. U is equal to x squared y plus xy plus a y plus an x. Now let us try another one. Try this one. If you got a y plus a 1 over x dx plus a x dy equal to 0. So first you need to find out what is going to be the fact. Is this going to be an exact equation or not? And if it is, how can you solve it? So the first thing we need to do, we need to know that this is actually the n, and this is going to serve as the n. We could well do that. Now, if we want to do that, first we know that if we got m as a y plus a 1 over x, this is obviously going to be a m, which will be equal to y divided by 1 plus a 1 divided by x. Now I could well add this. We know that the lowest common multiple between 1 and x, that is going to be an x. So if we got 1 going into x, that is going to be x times. Now x times y, that is going to be xy. And this will be plus x into x, or x divided by x rather. That is going to give us a 1. So here we should have a 1. And that is what we got. So this stuff, this could also be written as a xy plus a y. So I'm going to rewrite this expression. In this case, we should have this stuff, which is the m, as xy plus 1 divided by x. And here we got a dx. This is going to be an x dy. This is equal to 0. Now, in order to take this away from here, I could well multiply through by x. So we're going to multiply through by x. So if we got that, this is going to be xy plus a 1 divided by x dx plus a x dy. This is equal to 0. Now we're going to take this and have it multiply with this. That is basically going to help us cancel these out. Next up, we're going to take this again and multiply it with this. That is going to create an x squared. And we're going to take the x to multiply with a 0. That is basically going to give us a 0. So here we should actually have a x, y plus a 1 dx. This is going to be plus x squared dy. That is going to be equal to 0. So this is really a better representation of that question as compared to the other one. So we're actually going to use this one. I need to take these out. So here what we actually got, that is actually this stuff. So I'm also going to take these one out. Now from here we're going to say that m, that is equal to xy plus a 1. And we know this is the same thing as partial u, partial x. And we also got n. Now n is equal to x squared. This is going to be partial partial u, partial y in it. Now we need to look at this. This is basically what we got. You need to find out, is this actually a exact differential equation? So first we need to find what is going to be partial n, partial y. That is the derivative of this with respect to y. Now here this should be an x. Just an x. Now let us find for the n. That is going to be partial n, partial x. That is going to be the derivative of this, which is actually a 2x. Now this should almost be an exact differential equation, but it turns out to be that that is not actually the case. We got a 2x on this other side, while on this we got an x. So we don't actually have partial n, partial y being equal to partial n, partial x. They are not actually equal. Now remember the original question we had. That was a 2x. Oh, making a mistake there. So this is a y. We got a y plus a 1 over x dx, and we also had a x dy in it. Now let us say this is the m, and let us try to find out what it's going to be. So here we have a y plus a 1 over x. If you got a partial m, partial y, that is going to be the derivative of this with respect to y in it. Now here this is obviously going to be a constant. So the derivative of a x, that is a 1. Whoa, the derivative of a y, that is a 1. Now if you had a partial n, partial x, that is the derivative, because we know from here that n is equal to x. Now if you wanted to differentiate this with respect to x, that is going to give you 1. Now as you can see, by working this transformation, that actually changed it into stuff which is actually not workable. So this doesn't actually work. This transformation, this is not correct. So that is obviously different from this one. So we're just going to stay with this one. So first we got y plus a 1 x dx, that is plus a x dy. This is equal to 0. From here we know that m is equal to y plus 1 over x, and this is actually equal to partial u, partial x. We got the n is equal to x, and that is equal to partial u, partial y. Now as usual, we need to find the integral of n dy, and that is going to take us back to the u in it. So this is going to be integral x dy. This stuff is going to take us to x, because we got this. And obviously we're going to have this stuff cancel these out. So this will be equal to x multiplied by y. That is going to be xy. Now this will be xy plus t of x. Now we need to take this, because we're going to call these as a u. We need to take it and differentiate it with respect to x. So this is u equal to xy plus a t of x. Now du dx, I'm going to write that as a partial u, partial x. That will be equal to, in this case this is going to be a y plus a t prime of x. Now we already know that this stuff, this was equal to, well, I think I'm just going to take it out and write it on these other side. We already have another du dx. That was equal to y plus a 1 over x in it. Now since we already got du dx to be du dx, we're therefore going to take this from the first one, which is actually a 1 plus a 1 over x, and on these other side we're going to have a du dx. That will be a y plus a t prime of x. Now, obviously, as usual, this stuff is going to get cancelled. So we're just going to have this equal to this. So I need to take these ones out. So we got t prime of x. That is equal to 1 over x. Now, as usual, we need to integrate both sides with respect to x. So this is going to be integral t prime of x. And on this side, we're going to have an integral 1 over x dx, obviously. Now this is going to give us a t of x. On this side, we're going to have the integral of 1 over x, which is obviously an ln x. So that is what t prime of x is. Therefore, we're going to see that u is equal to xy plus ln x. So this is actually going to be the answer to the question. U is equal to xy plus ln x. Now we're going to move on to the next question. Try working this one. Feel free to pause the video and try doing it out yourself. So as usual, the first thing we need to do, we need to call m as a first stuff. So that is going to be 2xy plus a y multiplied by cos xy. Now obviously this is going to be a partial u partial x. And we also got an n. Now that is going to be x cos xy. And obviously this is a du dy. Now we need to find out whether or not it is actually an exact equation. So we need to differentiate each of them. So the first one, that is the m with respect to the y. So if I wanted to differentiate this with respect to y, that is obviously going to leave me with the 2x in it. Next up, I got this stuff. Now this is actually different from this, which is here. We got a y, which is a new function of itself. This is actually a linear function. Now this linear function is added, that is actually multiplied to a periodic function. This is a periodic function, so these are actually two functions carrying the variable y, which is actually the basis for differentiating this whole stuff. So in that case, we actually need to use the product formula. Now we know that if you got a u multiplied by a v, the derivative of this will be a v du plus a u dv. So we're going to mark this as a u. We're going to take this to be the v. So first we need to have a v. So that will be cos xy, standing for the v. And then we got du. Du means the derivative of the u. Now, obviously that is with respect to x. Well, with y rather. So that is going to be a 1. So I'm going to have a 1 there. Now u, we got u to be y multiplied by the derivative of this stuff. Now this is going to be cos xy. Now what is the derivative of a cos xy? That is obviously a negative sine xy. Well, need to rewrite that. Now we need to take that stuff which the periodic function is attached to and differentiate it also. So that is going to be the derivative of xy with respect to y. So in this case, we know x is a constant and the derivative of y, that is a 1. So that will be x multiplied by 1, which is obviously an x. So this should be an x. So from here, we're going to see we got this. So let us see what it looks like. So that is going to be 2x plus a cos xy And here we're going to have a plus y. And here, this is going to be a negative x sine xy. So this is what you got. I think I'm going to make this to serve as a this. So we're going to have this. I'm going to have this. So this gives us 2x plus a cos xy minus a xy sin xy. Now I'm going to write that here. So I need to write it over here. That is all. Partial m partial y. That is equal to 2x plus a cos xy or minus xy sine xy. Now we're going to try it for a second. Now we got n to be this, so we want to find out what is going to be dn dx. So these, obviously, these are new functions. So what we need to do is we need to take up this stuff and use the product formula. Now we know this is going to be the first one, so let us see that is u, and as we multiply by v, that should be a v du plus a u dv. Now v in this case is a cos xy. Du means the derivative of this, so that is basically going to give us a 1. Now next up you got u. Now u is x, so we got x there. And this is going to give us we got cos xy, which we need to differentiate with respect to x. So obviously that is going to give us a minus sin xy. Now we need to differentiate xy with respect to x, so that is going to give us a 1. So if I plugged it back, this should actually give me a cos xy, and here we're going to have a minus xy sin xy. Now here is something very interesting. From the first part, we had that okay, so I'm just going to write it first. This is going to be cos, so we got cos xy minus a xy sin xy. So this is what we have. Now we knew dm dy, that is equal to a 2x plus a cos xy minus a xy sin xy. Now as you can see, we have the first two terms of this one be equal to the second, and the last term of the first one. But we do not really have a 2x in the first case. So what are we going to say? Is this truly going to be a exact differential equation? Obviously not, because in this case we do not have a 2x for dn. And if you got that, that means this is not actually going to work. So this is not an exact differential equation. Now let us try just one more. So let us say you got this one. So this is the last question. Feel free to pause the video, try working it out yourself. And the first thing we're going to do is m. M is equal to e to the xy. That is y multiplied by e to the xy. That will be minus 2xy to the third. Now, as usual, we know this is du dx. Now let us just find out what is going to be partial m, partial y. So as usual, these are two different terms. So we know that uv, that will be equal to v du plus a u dv. So in this case, I'm going to call these as a u, and this is going to be v. Now v du, v, that is going to be e to the xy multiplied by du. That is the derivative of a y with respect to y. That obviously is going to give us a 1. And we got u. U is a y. And we need to differentiate this stuff. That is a v. If you wanted to differentiate that, that will be e to the xy multiplied by the derivative of xy. Now we need to differentiate xy with respect to y. So that will leave us with an x. So we're going to have a e to the xy plus a xy, e to the xy. So I need to write that here. This will be e to the xy plus a xy, e to the xy. Well, that is just for the first part of m. So we need to find out that for the second. Now we need to differentiate this with respect to y in it. So in that case, this stuff is going to stand as the constant, which serves as a coefficient. So we need to differentiate y cubed, which obviously will be 3y squared. So here we're going to have a e to the xy plus xy, e to the xy. This will be minus 2x. Well, I need to write it all out. So this will be 2 multiplied by 3, which is going to give us a 6. So we're going to have a 6xy squared. This is partial m, partial n. Now let us try to work that for the n. Now we know n is equal to x multiplied by e to the xy. That will be minus 6xy squared. This is minus 2y. Now we need to find dm, because of course we know this is du dy. So we need to find dn dx. Now as usual, that is going to be v du. Whoa. So that is a mistake on my part. Need to take it more gradually now. So first, we got this stuff. X e to the x multiplied by y. Now we need to work this. So first, we're going to call these as a u. And this stuff, we're going to call it as the v. So uv is equal to v du plus a u dv. So what is a v? In this case, we got the v to be this stuff. So that is going to be e to the xy multiplied by du. Now what is du? Du means the derivative of this. That is with respect to x. So that obviously is going to give us a 1. So I'm going to have a 1 there. Then on this side we have an x, which is a u. And then we need to work the derivative of this, which is going to give us e to the xy multiplied by what we know as the derivative of xy with respect to y. So in this case, we need to differentiate this rather with respect to x. So that is going to give us a y. So we got this. This is e to the xy. That will be plus xy e to the xy. So that is what we're going to have. Now that is for the first part. So I need to take this and rewrite it. So we got this. I think I'm going to take these out also. So this is what we have. We have the first part to be that. And I think I need to wipe these out. Well, so this is going to be e to the xy minus a 6xy squared. Now we know that n is equal to e, well, x multiplied by e to the xy minus a 6xy squared minus a 2n. Now this is similar to du dy. Now this, we differentiated it with respect to x, and this is what we got. Now we need to take this and differentiate it also. So if we differentiated this is obviously going to be a negative 6x, and that will be multiplied. Well, that is with respect to x in it. So I need to change this. I'm going to rewrite it now. So this is going to be minus 6y squared, and I need to differentiate this with respect to x. That is basically going to be 1. Now for this one, we need to differentiate this with respect to x. Now obviously there is no x here, so that will be 0. So in this case, this will be minus 6y squared. And so that will be basically it. Right? Okay. So I need to take these out. So in this case, we know that partial n, partial x, that is going to be equal to e to the xy plus a xy. We got, well, e to the xy. And here we're going to have a minus 6y squared. So that is basically it. Now, as you can see, this stuff is not the same thing as this. And so for that reason, for that case, we're going to say that partial n, that is not equal to partial n. Whoa, sorry, we made a mistake there. This should be partial y. This is not equal to partial n, partial x. Therefore, we're going to say that this equation is not exact.